find the antiderivative of the sine x over 1 plus sine square x, notice that you can express this as sine x divided by 1 plus 1 minus cosine square x dx. So basically, you should recognize that sine square x is equal to 1 minus cosine square x. Right, so as a result, this is equal to what? Sine x divided by 2 minus cosine square x dx. Okay, so now if you use the U substitution, you will get cosine of x for the u. Du is going to be negative sine x dx, right? So there will be a negative sign in front of the integral, right? So this will be 1 over 2 minus u squared du. So notice that you can make it easier by removing the negative sign, basically applying the negative to the denominator, so that there will be a positive coefficient in the integral, and basically the signs change for the u squared and for the 2, so you can write it as u squared minus 2 du. Right? And notice that using partial fraction decomposition, 1 over u squared minus 2 factors as a divided by u plus radical 2 plus b divided by u minus radical 2, right? So these two factors, when multiplied, will give you u squared minus 2. Right? And don't be thrown off by the roots. Right? Multiplying both sides of this equation by u squared minus 2, we get 1 on the left side. A multiplies the second factor, and then b multiplies the first factor. Okay, so now comparing coefficients, what do we get? First, the constant. First, the constant means that we can have 1 times negative radical 2a plus radical 2b. Now, for the second equation, we're going to compare the variable u coefficients, right? There's no variable u on the left, so there's a 0 on the left side. A multiplies the u, so it's just a plus b, right? b times u, so b is the coefficient, b. So now guess what happens? We need to eliminate one of the variables. We can eliminate the a, right? Multiply both sides of this equation by radical 2, right? Just by radical 2. This will become radical 2a, and then add these two equations as a result, and that will eliminate the a. Right? So radical 2 times the second equation added to the first equation will eliminate variable a, and will only leave you with the b variable to solve for. 1 times 0, right? 0 times radical 2, 0 is still 1. Negative radical 2a plus radical 2a eliminates the a, perfect. Radical 2b plus radical 2b is 2 radical 2b. Right? So that means that the b is equal to 1 divided by 2 radical 2. 1 divided by 2 radical 2. So a must be the negative of that using this original second equation, right? A is negative 1 over 2 radical 2, right? Because the sum of these two is 0. So this must be the negative version of the b. Right, so now what do we have? We have the integral. As a result, we can break up this integral into partial fraction decomposition into two integrals, right? We will have a is negative, so we can put a negative outside. Well, how about we put the entire a outside, negative 1 over 2 radical 2. Then, right, u plus radical 2 du. And then plus b, right? Plus b over 2 radical 2. And the denominator is u minus radical 2 for the b, right? Du. So now, as you can see, there's an ln here, right? If you set this u plus radical 2 as v, dv will be 1, right? So no new numbers introduced, you can go straight to the ln. But I would go first with the ln of this because of the positive coefficient, because this is subtracted, right? So let's start with this one. It's 1 over 2 radical 2 ln absolute value u minus radical 2 minus this 1 over 2 radical 2 ln of this denominator, u plus radical 2 plus a constant. And now let's put everything back in terms of x, right, the original variable. So it's going to be 1 over 2 radical 2. Now here's the trick. 1 over 2 radical 2 is something that we can take out, right? So we can put it as 1 over 2 radical 2. Now note that if you subtract one ln from the other, it means that the inputs of input of the ln you subtract will be the denominator of a fraction for the ln, right? So what I'm saying is we're going to have ln of an absolute value of the fraction. The denominator of this fraction, from the properties of the logarithms you should recognize, is going to be this input because it's the subtracted ln, right? So it's going to be u plus radical 2, but u is cosine, right? So cosine of x plus radical 2. The numerator will be the ln, the input of the ln that you're subtracting from, right? You're subtracting from this, so it should be in the top using the properties of logarithms, right? You should recognize this. So u minus radical 2, u is cosine, right? So cosine of x minus radical 2, right, plus a constant, right? So you're actually simplifying the result as a result, right? You're simplifying this result instead of writing two ln terms, right? You're putting everything in one chunk answer like this. Okay, so and of course you can simplify 1 over 2 radical 2 by multiplying the numerator denominator by radical 2, right? You're rationalizing the denominator. Okay, so you can put this as radical 2 divided by 4, right? So radical 2 divided by 4, right? Because radical 2 is on the top, but radical 2 multiplied to the bottom gives you 2 here, times 2 is 4, right? So this is the better looking answer, cosine x minus radical 2 over cosine x plus radical 2 plus a constant, right? So this should be the correct answer. If you got this answer, it means you did the correct work. Hope this was a lot of fun. Thanks for watching and see you in the next video.